I like to say that physicists can tell you what's conceivable, chemists tell you what's actually possible, and biologists tell you what actually happened.
So,
So,
that's great.
but with all of us together, we're getting a pretty good picture of how it all came together.
Welcome to Closer to Truth. I'm Robert Lawrence Kuhn, and I'm speaking with Frank Wilczek, recently the winner of the Templeton Prize in 2022. Of course, he is a Nobel laureate in physics in 2004, and it is great to see Frank again on Closer to Truth. What I'd like to do, Frank, is to really get into your ways of thinking by tracing the arc of your books. And let's go through your thinking in, first of all, in writing books for broad audiences.
Well, I think those of us who do research in many branches of fundamental science these days produce primarily a cultural product. We're astronomy is not going to put bread on the table or affect people's economic lives very much. Certainly not directly, but it's a cultural thing. It's a matter of understanding the world better and expanding our minds. But to get full value out of the cultural product and to justify the kind of support we ask for and need to pursue this effort, I think we should give back to the public. Also, it's just a wonderful story we have to tell. It's fantastically beautiful and mind expanding, and so I like to tell it. And that's been the motivation for my early books. And now when I'm moving into kind of areas that were traditionally thought of as philosophical or even theological, I've realized that science can offer very valuable insights in those directions too. And so I think philosophy is too important to leave to the philosophers, and morality and religion are too important to be left to the professionals. Right?
There are some physicists who think that philosophy and theology certainly are not shouldn't be allowed in common discourse.
Well, like it or not, they are, and you can, yes. And if scientists refuse to occupy that space, there'll be charlatans and aggressive people with no particular qualifications who are only too happy to do that. Right?
Yeah, but I think what I hear in you is not just an obligation to communicate, but a process of your own personal learning and your own personal expressions and expansions, which is a
Yes,
deeply
very much
powerful.
so. Very much so. When I was growing up, when I was sort of in my early teen years and even earlier than that, I grew up in Roman Catholic tradition and went to catechism class and things like this, and I took it very, very seriously, and thought about what it all means, what the secret meaning of things was, that there was more to it than appeared on the surface, and that there were powerful secrets that you could learn. And as I learned more about science, I ceased to believe in the details of that tradition or in the authority of the dogmas, but this idea that there are powerful secrets out there and that we should try to think big and understand it, that's really stuck with me. And I've been trying to fill the void ever since. So it's taken me a long time, but in recent years, I think I'm starting to get ready to do it. That's right.
Well, that's a great attitude. That's the way I feel as well. We've done Close to the Truth now for 23 years, and I feel just getting started, and so much more to explore. So we are, our mentalities resonate. So I want to start with the first book you did, Longing for the Harmonies, which I think was published in 2007, which was 3 years after your Nobel Prize was given. And
I think
so,
it was first published long before that.
oh, okay, I saw it
Yeah,
2000.
I don't remember when it was originally, but I think it probably was in the 1990s, because we did it, or even maybe the late 1980s, because I started writing it at Santa Barbara. And that was a labor of love, maybe in two senses, because it was very much inspired by my wife, Betsy Devine, who was very enthusiastic about the idea of bringing frontiers of science to the public, and also with the idea of us doing a big project together. And so that was a joint authorship on that book, and that I was a very interesting and rewarding experience. Got me started in thinking about the challenges and getting engaged in the challenges of communicating what the world is all about, and how strange it is to the general public.
What were some of the major themes of the book?
Compared to my later books, I would say it was uh, a more straightforward exposition of what were then, and in many ways still are, frontiers of physics, such as understanding the early universe, understanding the fundamental laws, and spelling out where they could be, in what directions they could develop in the future.
I have to make an aside because I read someplace that you met your wife, Betsy, who was very gracious when we first filmed with you 15 years ago in your home, and we invaded it with all of our
Yeah, she
cameras.
still is.
And she was great. But I read that you met her in some sense related to the 1972 World Chess Championship with
Yes.
Robbie Fischer and Boris Spassky, watching it on television because I was transfixed by that. I wouldn't do anything else. It was this wonderful,
It
frizzy-haired
was a
guy,
happy.
Shelby Lyman, in the most unprofessional studio, and that
Right.
it transfixed me. And when I saw that,
It,
if that's a true story, I mean, I really resonate with that.
it was a happening. Uh, at that time, we were both graduate students at Princeton. And at Princeton, there's a place called the Graduate College where many graduate students are housed. And we were both there. And in that whole thing, there was one television, which, which was down in a special room. And people got together, maybe 30 people, 40 people in this room, and watched the chess match. There were people, and Betsy was one, and I was one, and there's a lot of kibitzing going on, it was a real happening. And it turned out for Betsy and me to be a bonding experience because she was very impressed by my accuracy in predicting the moves.
That's terrific. That's a great story. Okay,
Mhm.
let's go on to your book that I think was 2009, The Lightness of Being. Um, and what motivated that to begin with? And then I know there are three big categories. I'd like to discuss each of them.
Well, the that was post Nobel Prize, and basically was explaining what the Nobel Prize was all about, why, what we discovered, and what its broader implications are. Because the citation for our Nobel Prize was for the theory of asymptotic freedom and the strong interaction. which doesn't really convey to an outsider very much, I think. but to me, one of the most profound and beautiful implications of the theory is that it explains the origin of most mass. So it sort of fulfills E equals mc squared in a profound way. Uh, that is, we start in our theory of the strong interaction, which is what the prize was all about, with building blocks that have essentially no mass. So in the case of the gluons, they have strictly zero mass. In the case of the quarks that are important for protons and neutrons, they have very, very tiny mass, much smaller than the protons and neutrons themselves. So almost all of the mass of protons and neutrons, and therefore of us, which being built from protons and neutrons, comes from pure energy, according to not E equals mc squared, but m equals E divided by c squared. If you just do the little bit of algebra, you can start with a concentration of energy in a package called a proton that is the energy of essentially massless particles moving around. So it's their kinetic energy. And in our theory of the strong interaction, that's where the mass comes from. So so it's a really, I think, extraordinarily beautiful triumph of scientific understanding.
So, just a brief historical understanding of where we've come from. We used to think that the atom was this hard little ball, like a billiard ball, and then Rutherford and others sent X-rays through it and found out that it was vastly empty space and only a tiny nucleus in the middle. And then we thought
Right.
that was the hard little ball. And then you found protons and neutrons, and that was the ultimate ball. And now, of course, as you've done within the proton neutron, you have three gluons, but the mass of those gluons is only about 1%.
That's right.
1%, but the
quarks.
the quarks are 1%. And the
Yeah,
gluon's
and
zero. And
zero.
so all the rest is
The mass is really coming from energy.
that's really amazing, and and that is the literal composition of what mass is energy divided by, because we
Yeah,
normally see E equals mc squared. You just flip it around, and so if you want to
right,
calculate the mass, it's you know what the mass is, you know what the speed of light is squared, and so you see this enormous amount of energy that you need,
right.
because if you have
And now,
light squared in the denominator is a big number.
yeah, so there's plenty. Yeah, so for by ordinary standards, there's a lot of that mass represents a lot of energy,
Mm.
and in atomic bombs and nuclear reactors, a very small percentage of that energy is liberated, and we know that that's a lot of energy.
The book "The Lightness of Being," which is a wonderful title to take off on the movie perhaps, but the lightness of being this, that the actual the mass is really the energy, is a wonderful title. The three categories that you've had in the book: the origin and centrality of mass, which we've just discussed. Then the second part was the feebleness of gravity.
Yes, well, because we understand the origin of mass so deeply, you can revisit the question, which is a vexing question in the foundations of fundamental physics, which is why, as it acts between the basic uh, particles of matter, why gravity is so much weaker than the other forces.
I think it's between electromagnetism and gravity, something like 10 to the 40th is something.
That's right. It's about 10 to the 40th. They're both 1/r² forces, so you can make a fair comparison. And if you measure them between electrons or protons, you get fantastic numbers like 10 to the 40th.
That's unbelievable number.
But the point is that our modern understanding is that well, it's explained in the book, and it's not easy to encapsulate in just a few words. But basically, that if you go to short distances or high energies, and analyze phenomena in those regimes where we think the basic processes are more revealed, less obscured by the kinds of effects we calculated and got the Nobel Prize for. If you sort of strip those away, go to shorter distances, you find that gravity gets stronger and the other forces get weaker. Certainly, the strong force gets much weaker, and they come together. So, reading it the other way, if you start from the most basic concepts at short distances and run the truly short distances and run them to the larger distances that we experience, larger meaning the size of atomic nuclei, uh, then it all makes sense. Then you can understand why gravity. So gravity starts equal, but doesn't stay equal because, as a function of distance, it changes in a different way that we understand. And they start from equality, but gravity really does get weaker. The other forces, much less so. Mhm.
The third category in the book is about beauty and truth, which seems to be very different from the physical grounding of centrality of mass and feebleness of gravity. Third part talks about beauty and truth. So why and how do you make the transition?
Well, an important characteristic of the theory that's central to uh, lightness of being, our theory of quantum chromodynamics, the theory of the strong interaction, is that the way the theory is constructed and the way we found it is that it's a mathematical embodiment, or it's an embodiment of mathematical perfection. Let me make an analogy. Plato uh, made a mathematical theory of atoms based on there being four different kinds of atoms plus an atom for the whole universe, so really five, that he identified with the Platonic solids. So possible forms of perfect symmetry, and that you'd have a correspondence between forms of perfect symmetry and the reality of the physical world. Well, what we find in quantum chromodynamics is an embodiment of the idea that symmetry controls the properties of the world that goes far beyond anything Plato could have imagined, but also in another direction. That is, it's true, and you can check it, and it has lots of concrete consequences that you can build on and check. So that's what I was talking about, or put it maybe more concisely with less specifics. This is what Einstein said, is that the most incomprehensible feature of the world is that it's comprehensible. And the way it's become comprehensible is because the laws have this kind of uh, mathematical symmetry and beauty that leads us to them.
And so that brings up, how are you defining beauty in terms of elegance is another word that's used, simplicity. I think didn't Einstein say, make it as simple as possible, but not simpler, something like
Right,
that.
right. So that's exactly the art, and this was spelled out in really those thoughts were taken to another level and spelled out in A Beautiful Question, the third book. And um, there, I was more specific about the kind of beauty that's involving symmetry.
Okay, well
This,
let's go to that now. So I want to define the book. So that's the third book, A Beautiful
okay,
Question,
yeah,
subtitle Finding Nature's Deep Design, and I think that was
yeah.
2015.
Yes,
So
sounds right.
and symmetry, beauty, and I think economy, efficiency, or something was
Yes.
there. So let's go into each of that and understand the third book. First of all, after dealing with beauty in the lightness of being, what motivated then a whole new book focusing on beauty?
Well, I thought there was a lot more to say about it,
Okay.
and I thought about it more, and really tried to do more justice to kind of the humanistic or common understanding of beauty, and not sort of and take it down from the clouds, down to earth, down from the Platonic ideal into into things that are more tangible. Uh, and so, specifically, for instance, uh, discussing symmetry in terms of the artistic practices of different cultures, and showing
Yeah.
examples of how they've used symmetry as an aesthetic principle to guide designs. And you see that all in many, many cultures in designs that are used for, well, on walls or ceremonial buildings. And in our own culture, also on tile floors, in mosaics. And it's carried to extraordinary heights in Islamic art, where the patterns of symmetry are very, very explicit. And a place like the Alhambra is almost like a mathematical museum, where they exhibit the different kinds of symmetries that are possible for wall designs. And in mosques, you see motifs that are sort of like mosaics, but not that build on putting together many symmetric objects into patterns that themselves have symmetry. So they're kind of layered symmetry, like almost like in the spirit of fractals. And that so I was able to document it quite a bit. And then I also thought more deeply about, so that's one form of beauty that you can put your finger on, that's shared by large parts of artistic practice, and on the other hand, science and the properties of fundamental laws. And the other one you alluded to, economy, I think is the other big one. Uh, well, it's the idea that you can arrive at a description of nature that is very concise and yet very precise. So you can get a lot more out than you put in a sense. You put in the rules, and if you let a computer, you could teach these rules to a computer with a very short program. It would be much shorter than any modern operating system, or Word, or any the and yet, if you let the computer, gave the computer a lot of time and uh, interpreting those laws, it could begin to build up the structure of matter, and the how different nuclei are made, and the periodic table in principle, and chemistry and everything. It's all in there potentially, if you could compute powerfully enough and long enough. So the idea that we would be able to do that, I think, was is an extraordinarily beautiful thing in in the set in the idea that you get out more than you put in. And people admire that at a visual level, when you look at fractal designs and how attractive they can be, and people gasp and wonder. And these are things that were essentially constructed by, in their modern form, in their full glory, by mathematicians and computers, and yet are by any standards attractive aesthetic objects. And they kind of also symbolize the way the laws unfold from simple seeds into extraordinarily complex and rich consequences. That And I think that once you appreciate it, is stunningly beautiful. Is really stunningly beautiful.
How do
And what work?
how do physicists use that beauty to discern new insights or to test one equation over another? You had a nice phrase
Yeah.
called aesthetic guidance. I like that phrase.
Yes. Yes. So let me give you a couple of examples. So one example, a historical example that probably many of your listeners and watchers will recognize is Einstein's equivalence principle. So there was an unexplained fact that was put in was how should I say, an essential addition to Newton's laws of gravity, and yet was not logically necessary there. That is that the mass that appears on the right hand side that tells you how powerful the gravity exerted by an object is the same as the mass that appears on the left-hand side that tells you how easily it's deflected in response to forces. It was an unexplained regularity of nature that for all existing materials, those masses were accurately numerically equal. Uh, why? So this was kind of an aesthetic flaw in the laws. The laws were perfectly adequate, but they left this question kind of dangling in the air. And it's by wrestling with that question and seeing a way that could be built into the laws, so you didn't have to assume it, but it was a consequence of the conceptual structure, the equality of these two masses, that Einstein was led to general relativity, which is a fundamentally new, an improved theory of gravity. The axions, I think, are in the same tradition, very much so. There's a coincidence, apparently, in our understanding of the laws of nature that uh, they run so accurately forwards and backwards in time, and we've made a lot of progress on explaining that coincidence, but not quite there. And to really close up the story, we need a new idea. Is the new idea, how should I say, the new idea wouldn't be a good idea if it weren't beautiful, because it's meant to solve a problem of sort of why, why the laws are lopsided or have this coincidence that makes them less compelling, less coherent, less inevitable, if you like, than they could be. And so one looks for worthy explanations. And so there's a worthy theoretical explanation that leads to concrete consequences that we can go out and check.
Now, some people challenge that. Some physicists challenge the primacy of beauty, and whether they talk about the arbitrariness of planetary orbits or the number of free parameters in the huge model of the standard model of fundamental physics, where you have, I don't know, 26 or however many numbers you have to put in literally by hand to make the whole thing work. Now it works, but it just seems like a kind of as we say, a Rube Goldberg type of apparatus, that it works, but it has all these levers and gears, and you just have to work. And so
Well,
that's sort of a challenge.
let me push back on that one a little bit, because
Okay, good.
I mean, it is true that if you want to do justice to all the obscure phenomena discovered at accelerators with new unstable heavy quarks and leptons and their decay patterns, that you need to introduce quite a large number of experimental parameters. Now, it's not that large a number, it's a couple of dozen. So it's much less than the number of entries in the periodic table, for instance.
Okay,
uh,
fair enough.
but still, it's more than one or two, and it's uncomfortably many parameters. However, if you're only interested, or you want to focus on the important laws that for chemistry, for engineering, for everyday life, you don't need almost all those parameters are irrelevant. You can really get by with just a handful. I forget the exact count, but it's 4 or 5. So it's quite compact, our understanding, and the so okay, but still we could do better. And yes, and it's embarrassing to have all these funny numbers, and we can strive to make the theory more beautiful. So far, we've had limited success. but we try. And I think the two real success stories are Axions, which I told you about, which explains one of the numbers, which happens to be very, very small. So we can explain why it's very, very small. And the other is the ideas about unification, which sort of extend the ideas of asymptotic freedom to apply to all the interactions. And you see the interactions come together at a high scale. They didn't have to, but they do, and uh, that allows you to understand why they have the values they do at as we observe them. Because if they're going to join together quantitatively at short distances, they have to have specific disparate values that are disparate in a specific way at the distances we actually measure. So we can reduce among the important parameters, we have 4 or 5 that we can reduce by a couple if we include these extra beautiful ideas that are not haven't really been fully justified by experiment, but look pretty good. And so, and we'd love to make more progress, but so far it's been an unmet challenge. I'd have to admit.
Well, as again, Einstein said, you make it as simple as possible, but not simpler. So,
Not simpler, right?
so your fourth book, Fundamentals, published last year, beginning of 2021, I think. Um, you have two big categories, what there is, the things and stuff of reality, and then talking about beginnings and endings. There's two parts. We'll talk about it. But I was taken by the fact that you use kind of religious language in the book. You talk about, God and studying how the world works. We are studying how God works, and thereby learning what God is. And you talk about being born again, but you're not using these terms the way most people would think about them. You're
No,
not,
that's right. Yeah, and that was quite conscious, of course,
of course.
because I wanted at the same time to reach out to those communities and people who are comfortable with that kind of discourse. And I don't think we should leave them, leave them to the mercies of people who don't use that discourse in worthy ways. Uh, and it's a rich discourse. It's a rich language that it would be and a rich heritage that it would be a missed opportunity not to take advantage of. Personally, for me, it's very much what got me started was thinking in those terms, and as I trying this in my science, as it kind of disillusioned me from the detailed answers that I was getting in catechism class. It left me with the same kinds of questions. And,
I love what you say that that you can interpret the search for knowledge in science as a form of worship, and the
yes,
discoveries that are made as a form of revelation.
yes, I really feel that way, and I felt when I came upon that phrase, or what became that quotation, I had made a real discovery, something that really began at a new level to illuminate the questions that had been with me for a long, long time. Um, and part of this was by coming to terms with the history of science and understanding how Newton thought about the world and how Einstein thought about the world and how Maxwell thought about the world. And they were all in different ways informed by this kind of cosmic consciousness. Uh, Newton and Maxwell were believing Christians, and Einstein said he believed in the God of Spinoza, so he was kind of a pantheist, I guess you would say, or an atheist. I mean, people say both things about Spinoza, and I think it's not. in official documents, you can check off unaffiliated. So I guess that's unaffiliated. But unaffiliated doesn't mean you don't feel the significance of these questions and the need to take them on in some way. What does it all mean, to put it crudely, or why? What should we do? Can we get somehow insight from our profound understanding of physical reality about questions that traditionally have been thought of as philosophical or even religious?
Hmm.
Yeah.
So the first part of the book, what you call What There Is, has 5 chapters. I love the titles. There's plenty of space. There's plenty of time. There are very few ingredients. There are very few laws. And there's plenty of matter and energy. So weave that all together.
Two things that come out, I think, of profound understanding of the world that really emerge very clearly in when you think about them in the way that I presented in the book, which I think is a very fair way to think about them, is that cosmic humility is very much in order, but so is self-respect. Uh, so cosmic humility is very much in order because uh, by measures of how much space we take up as human beings. Human beings are very, very small. The biosphere is very, very small as a part of the universe. Uh, in terms of time, the universe is well over 13 billion years old, and that's a long, long time on human timescales. So, all of human history is a negligible compared to that kind of time. Uh, So cosmic humility is definitely in order. The universe is a very big, very uh, ancient place. We're sort of insignificant little newcomers. But on the other hand, we have we're big compared to the basic constituents of matter that we've learned. We're big compared to atoms. We're big, and we contain many, many significant information processing units. We have a lot of complexity, and we can have many, many thoughts in a lifetime. So, by objective measures, we're also quite large. And I love what Walt Whitman said: "Is I'm large. I contain multitudes." I think that's literally true. We can support a lot of complexity and a lot of thought and a lot of non-trivial understanding. Or to put it another way, we can understand a lot about the world, even though it's much bigger than us. At least we get to understand that it's much bigger than us, and we can in our minds we can get an image of it and comprehend a lot and get a lot out of it, even though we're not that big. Uh, and we're not that old, but we can see how old it is, and we can understand its history, and it's a marvelous thing out there for our appreciation.
Looking at the rough orders of magnitude, human beings are roughly a mid distance between the scale of the entire universe and the scale of atomic physics. So we can wonder in both, we can understand, research, and wonder and feel a kind of awe or transcendence looking in both directions, up and down.
Yeah, so we can have humility in one direction. If you think of big things as somehow more important, we can have humility in one direction and self-respect in the other. And so that's in a way the lesson of the first 2 chapters. Then the second 2 chapters is can be stated very concisely, which is the most, as Einstein did, the most incomprehensible thing about the universe is that it's so comprehensible. And he didn't know the half of it. It was only in the later part of the 20th century that we got very, very specific, powerful laws of how matter works that to this day stand up and seem to be more than adequate to provide a permanent foundation for engineering, biology, chemistry, all the practical aspects of physical reality. And we can understand it. We do understand it. The And then finally, when we do understand it, we and understand both the nature of the laws and also, the broad outlines of how it all came to be this way. Uh, we uh, we understand that there's a lot of potential in the world that we haven't exploited yet. So that's why I say there's plenty of matter and energy. If you take into account what human energy use is compared to what the sun potentially provides, there's plenty of room for growth, and of course materials too. We only scratch the surface of the different materials that can be used, and we don't use them yet in the most efficient and creative ways. And we're getting better at it because our understanding of the laws enables us to imagine new ways of sculpting matter and using its behavior that are going to make us smarter, live longer, and healthier, and be more powerful than in the past.
The second part of the book you call Beginnings and Endings, and here we have another 5 chapters with different kinds of characteristics. Cosmic history is an open book of 6. 7, complexity emerges. Emergence being a very important property that we focus on Close to the Truth. 8, plenty more to see. 9, mysteries remain. And 10, which I'm most interested in, is complementarity, you call mind expanding.
Yes. So we've touched in different ways on most of the what goes into chapters 6 through 9. We can go through that very lightly. Although there's a lot in the book that I won't talk about because there's much more than we can cover. But the law, we do have a picture of how the universe uh, emerged from an early condition, which was much simpler than what it is at present. And we have a picture of how you get from fundamentally simple laws and fundamentally simple starting point to the kind of complexity that we see around us. We have a broad understanding of how that happens, certainly how it's possible. I like to say that physicists can tell you what's conceivable, chemists tell you what's actually possible, and biologists tell you what actually happened. So, but with all of us together, we're getting a pretty good picture of how it all came together, and from simple starting points and simple laws, and then yes, that as we answer questions, I'm sorry, as we get answers, we learn how to pose more ambitious questions. And so I document how we're trying to find things like what the dark matter is, and we haven't nailed it all down yet, but we've been able to open new windows in the universe by building on the tools that previous discoveries make possible. There's a famous statement that yesterday's sensation is today's calibration and tomorrow's background.
That's wonderful. I saw that in the book.
So I document that. And then finally we come to chapter 10, which is complementarity, which is a principle that I've come to love. I must say, when I first learned about it, I thought it was kind of borderline bullshit. But as I've come to appreciate, become older and wiser and more experienced, I've learned that it's really mind expanding and a very, very useful thing to keep in mind, and it's wisdom. So complementarity is the insight that to do justice to a phenomenon or an object or a domain of discourse, you may need to, in order to answer different questions, you may need to use concepts that are very different, very difficult to translate into one another. They're and maybe even superficially contradictory. this is, in quantum mechanics, this is a theorem, really. You need to use, in order to answer questions about the positions of particles, you have to use one treatment of wave functions. And in order to answer questions about their motion, about their momentum, you have to use different methods of processing the wave function, and those methods contradict each other. They interfere with each other. So you can only do one at a time. That's really the content of Heisenberg's uncertainty principle. And it's a theorem. It's a mathematical theorem. But Bohr elevated it to a more general principle, and others, you can find hints of it in earlier literature. And uh, the idea that you may, in order to answer different kinds of questions, you may need to use, and in practice, often need to use very, very different descriptions. So, if you want to understand how a human being is going to behave in a social situation, uh, it would be very misguided to start with trying to find out their wave function in terms of quarks and gluons and doing a gigantic calculation. It's just inappropriate and practically impossible. And there are other concepts you can use fruitfully. Or if you think about, and philosophers have gotten themselves into all kinds of knots by not appreciating this, in my opinion. So puzzles about free will versus determinism, puzzles about is versus ought, they take on a new complexion and a new and quarrels between people with different uh, political points of view or religious points of view take on a different aspect when you start to realize that maybe they're not talking the same language, that and yet each of them can contribute some insight. Some of them might be more valid than others. Some might be just flat wrong, but it can be mind expanding to try to appreciate those different attitudes and how they help different people to make sense to their own satisfaction with make sense of the situations that confront them.
So it's really inferring from a basic principle of quantum mechanics, the wave particle duality, to ways of thinking about any kinds of problems, or it's a
Yeah, it's an
pro
attitude.
an attitude towards human appreciation of issues that we know it's true in quantum mechanics, and therefore
Yes.
how can it be true in other things? You refer to science religion kinds of disputes, even U.S. China relations. I mean, it's very broadly construed, but it's not a moral equivalence that therefore
No,
everything is exactly at the same level. We have to have
no.
this
It's
relativity.
it's rather it's kind of an invitation to mind expansion,
Yeah,
saying if you understand the other points of view, you have a larger mind than if you
yeah.
just dismiss them out of hand. That's
And that's terrific, and we need that in many many areas. I want to move on to the fifth book, the one you're working on now, futures. In terms of you believe that that humans through science can do great things in the future and what is possible. So give us from where you've come, what you're working on now, very briefly.
at the broadest level, you could say that fundamentals is about what is and how it got that way. Uh, I in futures, I want to talk about uh, what could be and what should be, uh, and also close the loop, going back from what should be to what is. The famously, David Hume uh, constructed something that's now called the Hume's guillotine, saying that there's no possible way to connect statements about what is to statements about what ought. So there's no logical way to convert from one domain of is to the domain of ought, which in broad terms is science versus religion or science versus morality or something. But And I agree with that. I mean, there's no logical way to bridge that gap. However, there are things that you can do that are informative and useful that move in that direction, I would say. So I like to think of a triangle. There's is, could be, and should be. And I think is the domain of, clearly the domain of science, but also could be is the domain of science, because if we understand the laws, we can understand what sort of what's possible, what we could possibly build, what future technologies could look like. So so we learn what could be, and we could scope out what different possible futures mankind might have based on these technologies. You can make plausible pictures of alternative futures. We can also scope out how things might go wrong. So from is we can go to could be, or we can say a lot about what could be based on profound understanding of what is. And then by spelling out what could be, we can think about what should be in intelligent ways. That you know, I think thinking about what should be without being constrained by what could be is less interesting and less fruitful than thinking about what could be and making informed choices based on really understanding what could be. So that's going to be the narrative arc of futures, sort of going from what is to what could be, and then implicitly, mostly, but also spelling out the choices for what should be, because some possible futures look much better than others. And I
Well,
think,
we look forward to it, and the invitation is open to come back and talk about it, and we'll promote it
yeah.
very substantially because it's obviously very
Let me
important.
just add one thought to
Sure.
close that, because I really want to close the loop. And it very much touches on things we've talked about, which is in science, the way we discover what is, surprisingly enough, is by thinking about what should be. We look at the description of the world we have and we say, it's not what it should be. It's a little lopsided. It's not as logically coherent as the God's last word should be. and so we make guesses about what should be, and it's turned out in several remarkable cases that guesses based on what should be have led us to correct inferences about what is,
Mm.
correct hypotheses about what
Mm.
is.
So it is a nice potential circle.
It's a kind of circle, right?
Very, very profound. Frank, what I'd like to do now, we have a few minutes left, is I'm going to give you a couple of topics, and each one of which we could spend hours on, but just give me your top of the head, 30-second, soundbite answer to a couple of really hard questions. So this is for fun. This is not as serious as what we're talking about. So, and you're perfectly free to say, I'm not going to answer that question. That's fine. Uh, so the first one is the multi-world interpretation of quantum mechanics.
I think, how should I say? So that's the idea that the wave functions of any reasonably complex system, let alone the whole universe, uh, contains many, many possible alternative uh, experienced worlds. So if you look in the wave function, you can identify possible intelligent beings that could have different kinds of experiences, and the wave function is very, very large, so you can find many, many different alternatives. Uh, and that's true. I think that's true. On the other hand, in that sense, there are many worlds in the wave function, but they aren't really fully realized worlds.
Oh,
so,
yeah.
so
Sounds like you're cheating here. Because,
at
I
least,
think the interpreters or those who promulgate many world interpretation really believe they really are there, and they're
yeah,
really splitting off at Planck
but it,
speed or whatever.
but it's a paltry version of reality, because it's not something share with one another or even experience personally. It's kind of a dream world. It doesn't have any dollar value, so to speak. It doesn't have any hardcore.
Well, they would say it has dollar value to each one of the versions of you and me that are in those worlds who think that all the other worlds have no dollar value. So
And maybe they're right. Maybe they're right, but I'm in
I'm,
this world, and
I'm with
on the
you.
other hand,
I'm with you on this one.
I think sometimes it borders on abuse of language. They talk about the other worlds being real, and so there, if you use a very, very loose definition of if reality is a very low bar, then yes, they're real. But if you're talking about what the way the word is used in common language and with its connotations, they're not real. They're not. On the other hand, at some level, the many worlds interpretation is saying just take quantum mechanics as it comes.
Yes.
Don't invoke outside principles like collapse of the wave function.
Right.
And I certainly agree with that. And that's what I do when I, especially, in recent years, I and many other people have been trying to take not Schrodinger cats, but Schrodinger kittens very seriously. So small scale versions of different worlds interfering with each other where they actually can communicate, and sort of making them bigger and bigger with more and more elaborate experiments. That's a very fruitful thing to think about. But they're very, very far from approaching fully fleshed out universes.
The second one is string theory.
Yeah, well, string theory is a very ambitious attempt to guess the fundamental laws of physics. I think calling without let me not say this I don't mean this in a pejorative way, but I think calling it a theory gives the wrong impression. It's not a theory. It's kind of a grab bag of ideas that haven't really come together as a single guiding principle or a set of equations that you can actually write down, let alone a series of predictions that can be checked experimentally. So it's very much under construction, and there's a community that calls themselves string theorists. So they think there is a body of lore and a body of technique that you can put your finger on that is called string theory. But it's not a theory in the sense that the standard model is a theory of nature. It's a project, and it might converge on a more conventional theory, and it might converge on a theory of the actual world that we inhabit. But I think the jury is very much still out on that.
Third one is strong emergence. Emergence, I know by itself, is quite a normal phenomenon. But strong emergence means that it is impossible in principle to physically predict the properties of some higher level by knowing everything about something at the lower level. Do you think that that definition of strong emergence is is a possibility in the physical universe or not?
Well, I suppose it's a logical possibility, but it doesn't seem to be the way the world works. If the world obeys the laws we think it obeys, that's not the way that doesn't happen.
Okay.
so,
That's,
so
that's
uh,
a full and complete answer to the question.
yeah.
So,
So it would be very. I don't. Without some specific proposal, I'm not sure how I can take that seriously.
the next question may be an example of that. I hadn't thought of that because I was going to ask you it separately. But you have a wonderful phrase in your book dealing with a subject that we cover a great deal on Closer to Truth, mentality, consciousness. You say, and I'm quoting you, any failure of Crick's, that's of the famous DNA Watson and Crick model. So Francis Crick had what he called at the time an astonishing hypothesis, which meant that our full mentality is entirely the product of circuits and neurons in our brain alone. That's what he
Yes,
called astonishing. But what
that
you said,
mind emerges from matter, right?
that mind emerges from matter, what you said, that is any failure of Crick's astonishing hypothesis, that would be astonishing.
Yes,
And
I think
so,
that's true, and I think that's also what Crick would say.
no, for sure he would, but for sure he would think that. For sure he would think that. He didn't mean astonishing for him. He meant astonishing for people who believe something else. I know that.
Well, it would have been astonishing as an historical development. It's certainly astonishing.
Yeah.
Uh,
So,
you
the
know,
question comes up, and mainly by philosophers, is what do you do about the phenomenology of consciousness, the qualia, the idea that the inner movie, our inner experience, whatever you want to call it, is so qualitatively different from anything that anybody has ever described in fundamental physics or hardcore neurophysiology.
well, I just refuse the premise. I don't think it is qualitatively different from.
Okay.
I don't see why it has to be qualitatively different. It's like, to me, it's like saying that computers will never play chess well because they can't understand these abstract concepts, or they, and but we know that something very close to human intelligence can emerge from things that we make. We know how, and they're getting closer all the time. And if someday a very capable artificial intelligence that you know talks like a person and complains like a person and says it's experiencing things, claims that it has consciousness, I think it would be highly hubristic to say no, you don't. I think
Well, the problem of
maybe
the mind, you don't know that I really have an inner experience. I mean,
exactly right, real exactly
you
right.
think I do, you expect I
Yes,
do, I act the way you do on many things,
yes.
but you really, really don't know. I mean, that.
No, that's right. That's right. So, I don't think we're ever. Well, actually, we might get, but if we could have imaging techniques that actually showed people in real time what's going on in brains and we knew how to interpret them and so forth, we could have insight into these questions, which at present are difficult to imagine even. But I think if we had that kind of insight, these issues would look very different, and then the paradoxes would
Mm,
dissolve.
yeah.
That's my
Yeah,
faith.
I'd probably disagree with that at this point. That there seems to be a more fundamental difference. But we have, plenty of decades and centuries and millennia where you and I can continue to talk about this every few years. So no problem. I want to end with this kind of question, what I call an axial question, and that is, as you have wonderfully described reality, and particularly in the arc of your books, as you've done, and where you're going to with Futures, your next book. Um, what is your approach to the nature of reality beyond the fundamental laws of physics? And the way I like to pose it is between two friends of yours and friends of mine, and participants on Closer to Truth. Steven Weinberg, who said that the more we learn about the universe, the more we see how pointless it is. And Paul Davies, who says the universe is about something, which is a nice phrase without any theological requirement whatsoever. So, pointless or about something. Where do you
Well,
fit?
Steve Weinberg and Paul Davies have both been very good friends of mine. And in the spirit of complementarity, I'd like to say that they both have valid insights. Uh, so,
Well, I
I,
can't.
I, so yes, if you're really hard nosed about it, uh, you can say that the universe doesn't have any point. Certainly, the fundamental laws are not moral laws. They don't have the appearance of moral laws. They're much more kind of abstract and but on the other hand, it's a glorious story that emerges, and Paul Davies is right to say that it, you can draw heartwarming lessons from that story. It can be inspiring and certainly mind expanding. So I think both are true, and by understanding both of them in the spirit of complementarity, you can reach a synthesis to say, what my synthesis would be, that the meaning of the world is under construction. And that,
It's a great tie-in to complementarity. I hadn't thought of that. You have this phrase somewhere in one of your books, which sort of summed it up for me. You said the world embodies beautiful ideas, but although this may inspire a spiritual interpretation, it does not require one.
yes, that's right. I think that's correct.
And yet, another point, you say that you give sort of a nod to Einstein's God of pantheism, as saying maybe that
Yeah.
reflects something of reality.
I think
How
that's,
do
well,
those things?
it's a very sympathetic idea to someone who's devoted a large part of their life to thinking about the nature of physical reality and discovering how wonderful it is. And Einstein himself uh, said he believed in his favorite philosopher, and I guess he said that he believes in the God of Spinoza. So, and well, Spinoza, yeah, I don't want to get into the technicalities of Spinoza. He had a kind of rigorous determinism and things, but kind of the idea that, ain't it grand, to put it really crudely. I think that kind of spirit uh, is is just somehow the right reaction to the way the world is.
So let's take that, because some kind of spirit. I would oppose that to, say, Bertrand Russell, who would say the world is, and that's all, which is his famous statement in his debate with Copleston when asked about origins of the universe. He said the universe is basically brute fact. It is, and there's nothing more I can say about it. But to say, using even the term pantheism or spirit in the world, that sort of gives it a different color.
Yes, but we still couldn't be talking about the same thing, because one thing that has been really surprising to me, uh, that has I've come to appreciate more and more deeply, is the potential of matter, or the potential of facts. So the we we see that in computers. Just, they're made from matter, made from components that we can understand and even design. We did design them, in, and yet they do amazing things. Things that you might not have thought was possible, based on just artificial. I'm sure a person, Ben Franklin or something like it, was, if confronted with a computer, or certainly someone not sophisticated, would say that there has to be a living body in there somehow, or there's a magic trick where there's a ventriloquist that somehow is making it happen. But it's matter. And so what? So when Bertrand Russell says the world is facts and that's all it is, that, to me, if by that he was trying to say that, trying to diminish it, I think that's wrong. I think that facts are not mere facts. Facts can build on each other and have a life of their own and dance together and do wonderful things. Right?
Frank, this has been absolutely delightful. I can't wait for futures to be published. We'll talk again and follow the trail. Thanks.
Thank you very much. It's been a joy. All right.
Really
Thanks.
enjoyed it.
All right. Bye for now.
Thank you for watching. If you like this video, please like and comment below. You can support Closer to Truth by subscribing.